I don't want to take up any more of this time. I do want to introduce our wonderful panel today. Speaking with you will be Rick Baldwin, Aaron Shatowski, and Sergio Borghese. Gentlemen, I'm going to hand it over to you. Thank you once again for joining us. Go ahead, Rick, all yours.
Okay, welcome. Welcome to the information session for the Mechanical Engineering Technology Technician Program. We're at the Welland campus, is where all of our classes are, as well as the labs, a lot of hands-on labs, industrial machinery that you get to interact with. The program itself, there's a 2- and a 3-year program. The Mechanical Engineering Technician Program is a 2-year diploma. You can start in either September or January. There's 8 months in the 1 year, then you have a 4-month summer off, and then another 8 months, and you're finished in 2 years in the technician. The technology program takes a little longer. There's 3 academic years. It takes you a little over 3 years to finish because of the co-op. But in this case, you end up with 18 months of co-op. There are 2 8-month co-op sessions. They're paid sessions. The students get great experiences. They make good industry contacts. The school arranges to post jobs, and you get to apply, go through the interview process, make industry contacts, and those are paid co-ops. Some in the neighborhood of $17, $18, $19, even $20 an hour, and even higher. You can start in either the fall or winter for those. The 2 programs share a common first year. So even if you're not sure if you want to do the 2-year or the 3-year, the first year is common, and any time in that first year, you can decide what to take. To switch it if you want to. So the first 8 months are the same. Coming in, 6 months in, 8 months in, you want to switch from one to the other. That's okay. You don't lose any time. It's all the exact same courses. It's only in that second year, when you come back in September of the second year, that you start to diverge a little bit. The technician has about 50-50 hands-on versus theory. The technology has about 60% theory, 40% hands-on, but the hands-on courses are exactly the same. So they get the exact same labs, you touch the same equipment, you take the courses together, but then the technology program goes a little more into the theory and design concepts and development. So there's a little more theoretical information there. Advances your ability to 3D model and do stress and strain analysis, those type of activities we cover in a little more depth in the technology. These are our CNC lathes. So from a hands-on experience, you can see in the top left here, a CNC lathe setup. And this is basically an industrial machine that you would see in industry. Some manufacturing shops use these Tormath lathes for production. It has a tool changer, multi-position tool changer. You can see a student there, hands-on changing tools, doing CNC programming. You will learn CNC programming, manual CNC programming, as well as something called MasterCam. And it's a system whereby you take a 3D model and it kind of generates the code. Now, of course, like any computer system, the codes aren't perfect. What ends up happening is you need to adjust it and teach it, move frames of reference. And we teach you how to do all that within the program, how to effectively create a quality part. Move on. The mills. So here's our CNC mills. So again, we had 4 lathes. I didn't mention that, but we also have 4 mills. These are vertical mills. You can see the tools in the bottom right on a little tray there. You can see an operator there, a student actually changing a tool. The machines have automatic tool changers. So similar to the lathes, we also have these mills, and you would get hands-on experience. These are in our lab. Again, the same type of programming, just works a little differently, but those are industrial mills that are available as well for you to learn on. And you will get hands-on experience. So you actually spend time touching the machines, running the machines, of course, doing simulations on your computer, and then downloading that, how all of that interacts, the quality of the part, how to get smooth cuts, what's the difference in climb milling, various machining opportunities that you're going to have to experience. Robots, we also have in the labs some ABB robots. These are industrial robots. They are the same robots that you would see in industry. The top left corner there, you're seeing a robot in a cage cell. And this is basically the meeting the ANSI or safety standards within industry here in Canada. There's a code. safety code for robotic installations. And we have full compliance with that code. So you actually see what an industrial application looks like. You can see in the top right, two students. So in this top right slide, I don't know if you can see my mouse, but there's a student there with a yellow checked shirt pointing. He's outside the cage. And then you see another student right in close to the operator. He's actually inside the cage, but if you notice, he's holding what's called a live man pendant. And it's a pendant where you use two hands, one hand on the back that holds down a button and another hand that can jog the robot at low speeds from a safety perspective. So here they are teaching, guiding the robot to pick a part up off a little orange pallets. So you can actually pick that part up off the pallet, load it into the lathe. The lathe can go ahead and do the machining and then unload the part. So we look at integrating those robots. So first of all, you learn how to program the robots because that's important to be able to teach an individual robot what to do. But then you actually get to interface that robot with a machine to see how it interacts and how it communicates, which is, again, the way of the world right now, right? Everything is going to automation more and more. And these robots are definitely, they are industry robots that you would see in the world. I worked myself in a Ford shop. And basically, we had the ABB robots that are similar to these, a little bit larger, but they work exactly the same. Machine vision within the robot cells. And Aaron has a lot of knowledge on this. Aaron has spent some time with these Cognex machine vision systems. You see that on the left picture there's a camera. It can actually take an image and look at an object. And with that vision, you can make decisions. Is the product good or bad? What's the orientation of the product look like? How is the robot going to pick it up? And so you will work with what's called Insight Explorer software, and that's Cognex. Cognex is an industry camera that you would see all over. Locally here, we have a GM St. Catharines engine plant. And that's my background is from one of the places where I spent 10 years working was at that engine plant. And at the time I left, we had about 20 vision cameras of these Cognex systems that we were putting in. And in the meantime, they have over 120 of these cameras all over, checking everything, checking whether people put spark plug wires on. You know, they're very common in industry, used for small checks, for quality checks. And we have these integrated in the cell. You can see the cage there, it's inside the robot cell. Oh, let's go back, computer integrated manufacturing cell. So here we have a system that has, if you look at the top left picture, there's a conveyor system. So that when we looked at the robot image earlier on, you saw the robots picking parts up off of a pallet, potentially putting them onto a CNC machine. This is the actual conveyor system that transports those pallets around. So it's a fully automatic, integrated manufacturing cell that models what you would see in industry. With the PLC controllers, you can see in the bottom left, students working on the PLC controllers. You will take PLC programming within this mechanical engineering technology program, and you will learn how to program PLCs on some small PLC trainers. And then later on, you go into the cell and actually basically integrate them. Integrate the PLC. The PLC is what controls that conveyor system. And it sends the information to the robots as to what's on the pallet, what to do. The robot makes a decision what to do with the part, goes to the CNC machine, which then completes the part, gives it back to the robot, which gives it back to the pallet, and then the system takes over again and keeps going with what's the next step for this part. And so you look at integrating that whole system. And as a student, you will have time, hands-on time to actually do the programming, do the development, and actually watch that system function. At the end, we have students who posted YouTube videos of their cell and as it functions when they're done their final project. And then you can use that as industry experience when you go off on your interview, showing, you know, this is what I was able to do. This is what we actually accomplished within the program. So there's a lot of hands-on, and I will note that all this equipment is industry standard. It is the same equipment that you would see out in industry. So you are getting hands-on, that type of hands-on experience. Next slide. Coordinate measuring machine, a CMM. This is a machine that's new to the college. This in the bottom left, sorry, the left side picture there. You see that machine? It's about, I think the price on this one was $97,000 US. So it's a very expensive measuring device. And we, in our advanced metrology, which you do spend time in our labs learning the science of measurement, which is what metrology is all about. This is a automated system that can actually touch a part and measure the diameter of a hole, the thickness of a part, the alignment of a slot, all sorts of features on the part. And so using the 3D model that you generate, that's been created, you can actually check the part to that standard to meet if it meets specifications. You'll be doing offline simulations. You have the software on your laptop that allows you to run this, as well as time on the machine where you are going to actually operate the machine, touch the part, and see if your simulation actually functions. So this is a very sophisticated device that you would see very common in machine shops now. Virtually all machine shops have some form of a CMM machine. In the world of automotive and aerospace, they would have these CMM machines in small offices off to the side. In fact, some of them even have them right out in the industrial floor as they manufacture products. The products go through the CMM, which then measures and compensates and adjusts machines. All sorts of uses for them in the field. You will learn what's called PCDMIS, which is an industry programming standard for these CMM machines that you can basically say that you've started to learn. Jobs and requirements out there. There's a lot of companies that look for quality engineers. A lot of our students, some of their first jobs are in quality. And one of the requirements often is that you are familiar with the CMM, how to read a report, how to generate a report, and how to program it. Next slide. 3D printing. Within the lab, we have numerous 3D printers. You see on the left side here, a complete assembly of a system. This is basically a model of a stamping die that would form material. Students have made that in a group where each person in the group was responsible for designing certain components and then getting them printed. On the right, you're seeing two industrial printers. The bottom right there, so those are both printers opened up. You will have access to those. You learn basically 3D printing in your very first year. Your first term, you're looking at 2D CAD. Second term, you're looking at getting into 3D modeling through Inventor already. And at that point, you start to learn and get exposure to these 3D printers. Not the way to manufacture everything, but it is a great tool for prototypes, low volume manufacturing. It's getting bigger and bigger in industry now. We have had students go off and their job is 3D printing. And we've had students in CoOp who went off and wanted to do some models where they were. The company didn't have any 3D printers. So what the CoOp student did is came back and asked us if we could print some models. That student then worked with that industry partner to actually create models for whatever they needed. The employer saw the benefit, hired that student as a graduate, hired him as a full-time employee, and bought 3D printers to start using them on an ongoing basis in his facility. So lots of opportunities, and that's kind of the link in our program between what you're doing in the course and what you're doing off on CoOp. You can always contact us for information, or students come back to get an example or bring the employer in. And that shows the employer the knowledge the student has, some of the experience they're learning, and then it helps you later on in establishing your career and deciding if you want, what part of the industry do you want to go into. The beauty of all these different machines that you're seeing here is you're getting exposure to lots of different technology, because we can't predict what jobs are going to be out there for you. Are there going to be quality jobs? Are they going to be manufacturing, CNC programming? What is your interest? So we expose you to all of these industries and you get some knowledge in them all, so that when you go off to apply, you have all those experiences. Because when you look at the job postings, you typically don't see a job posting for a mechanical engineering technologist or technician. If you go on to Indeed or Workopolis or those things, what you'll see is quality analyst, CMM programmer, CNC programmer, all these different titles that you actually, through this program, develop the skills to do that job. So what you have to look at is the skill set that you're getting. And that's the beauty and the strength of our program, is we have a very broad skill set so that you can apply to all these jobs. We haven't spoken yet, I'm going to get there, about the 3D modeling as well and the design work. This is some of the equipment you're going to have, but then there's this laptop, and we're going to talk about that very shortly. So let's go to the next slide. Fluid power. These are some modules we have that show industrial fluid. And as you can see, the students actually spend hands-on time. We have 6 of these benches. And so you come into the lab in groups of 12. So it's only 12 students in this class. So if it's a class of 60, there would be 5 separate classes. And you will work in pairs on this system. And here you're learning about fluid flow. You're learning what's a directional control valve, what's a cylinder, how do we use a pressure reducing valve, how do we regulate all these things, and how do we create motion or processes using fluids. You have connections that you make. You try and model systems, you do the modeling offline, you develop a system, and then you try and create it on this bench. And so you learn all the technology around fluid flow. And we have both hydraulic systems and pneumatic benches as well for air. Next slide. Modeling. So now I'm getting into a student sample. This is a sample. If you were in the technology program, this is your culminating project at the end. And what you're seeing here is a portable log splitter that was completely designed and detailed by students to meet a certain criteria. It had to be traderable, had to handle logs of a certain size, wanted it at a certain speed. So then you had to go out and come up with concepts, go out in industry and look at what are the different types of log splitters that are out there. And then you come up with your own design. And you can see here, they've actually created this design in Inventor. They've selected the components, selected the power supply, selected the control system, the cylinder, all of the components that meet the spec, bring that all into an Inventor, what's called the 3D modeling system on their laptop. Now you've learned Inventor throughout the years. On the right, you're seeing the hydraulic circuit. So this stuff over here is a cylinder with a directional control valve and some pumps, pressure reducers. So you're seeing controls of how the hydraulic system is going to operate here. You actually design the system. You pick the components that are going to go on this log splitter. The bottom left, the color picture down at the bottom, you see the title there, von Mises stress. This is doing what's called finite element analysis. And if you've ever looked at a design, and you'll see design engineers do this all the time, you create a design, but then the question is it going to hold under the loads? So through the program, you will actually learn how to determine the loads, what's called static analysis. So you're going to look at this thing called statics, where we apply forces. You can see the little gold arrows pushing. And so you're doing the finite element analysis of the structure that you designed, that beam with the weldments that are on it to support the log as we push the cylinder. You've designed it. And now you're going to look at the stresses and will this hold up or will it break? Because it's one thing to design it on a computer. Everything looks perfect and looks pretty. Then when you go in the industry, how do you know it functions? And one of the ways to tell if it's function is to do what's called a finite element analysis. That's done with an Inventor. And we guide you through that. In your culminating project, there's I know Aaron and Neil. Neil's not available today, but Aaron as well. And they get into all of the mechanics of materials, the design of components, and how we actually do all of that stress analysis. And so you will learn that. But again, it starts from basic physics in first year, and then we grow and we basically take that physics and expand it and apply it to specific applications. And that's the beauty of mechanical engineering, is we take what's this theory, if some of you have taken high school physics, you've done maybe grade 11, grade 12 physics, basic, Newton's second law, F equals ma. We take that F equals ma, and then in mechanical engineering, we expand it. We apply it to a specific applications and then detail it and go into it in more depth. Because it's not just F equals ma. We'll teach you that it's actually F net, the net force equals the mass times the total acceleration. That's a little different. It gets a little more involved. And then we look at the sum of all forces being zero as a basic static concept. And then we go into that more and more and look at the analysis. Even a screw, a small little screw bolted joint, we'll analyze that bolt. How do you pick an M8 versus an M10, a half-inch bolt versus a 3/4 inch bolt? What size do you need? So all of that analysis we go through, and that all builds up into this ultimate design of a fully functioning object. And now, when you submit the report, it's a complete detailed report that has all of the build instructions, the detailed drawings, the hydraulic circuit. And this report is, thick. It's going to be half-inch thick, bound report that you create that then you can take to employers to show, hey, this is what I'm capable of. This is the type of work that we learned. This is what I did. This is my abilities in the world of design. To do that, you have a laptop in the program. We're going to talk about that in a few minutes. So let's move to the next slide. Again, 3D modeling. So here's a little bit of detailed modeling. Get into that. There's a little gear system, a planetary gear system over on the right. There's a roller on the left, a lawn rower, and there's some detailed drawings there in the middle. And so you learn how to dimension it, how to create a detailed drawing, what's critical dimensions, what are reference dimensions, what are the tolerances, little things like you see that little triangle in the very middle of the drawing under what's called detail D. You know, what type of a weld? That's a symbol for weld all around, a 3/16 weld. And so what do those symbols mean? How do we detail the drawing? How do we determine what tolerance we should have on it? That's all studied within the course. And these are some examples of student work. Next slide. Some more examples of student work on the left. Again, detailed drawings. Up on the right, looking at the forces transmitted through a gear system. That's in Aaron's course that he does in level 10, machine design components, looking at a pinion speed of 1,850 RPM, 1,600 watts of power. What's the load that's being experienced? And how do we know, why is that load important? Because we need to understand that load so we can pick the components, the bushings and the shafts that support that gear. You know, sometimes you're not even working on design. You're working on the side of maintenance. I've had the experiences myself in the field of maintenance where something failed. You know, you're out in industry and the machines are running 24 hours a day. Something breaks. And then the question is, well, A, why did it break? What do we need to do to make sure it doesn't break? And sometimes that involves redesign. So you haven't designed it, but now you need to go and analyze that one component and was it appropriate? And so I keep talking about my experience. And what I failed to talk about before is Sergio and Aaron, myself, Neil and Joe, all of the instructors in the program, this is kind of a side, not on this slide, but we all have industry experience. Myself, I've been in manufacturing for 23 years before I came to Niagara College in the world of industry. In manufacturing everything from pipes to microcircuits that go in hearing aids. So small little objects, you can imagine the size of a chip that goes in a hearing aid, very tiny, up to large 4-foot, 20-foot length pipes that go out in the Trans-Canada pipeline. Aaron has spent a tremendous amount of time in project management, design, industry applications. Sergio's been out in industry. Joe has significant industrial experience. Neil Walker's another full-time professor. So one of the benefits of our program that you really need to focus on when you're looking at programs is how many full-time instructors and what is their experience level. We pride ourselves on the fact that we have a significant number of full-time instructors. So there's 5 of us who are full-time. The beauty of having 5 full-time instructors is we're on campus often and we're reachable. You know, you have issues. When we teach, we're in the office. Our offices are right near the labs. They're in fact across the hall from the labs. And we're there a lot. You can drop in. Our doors are open. We basically are there during the day, not necessarily there in the night. Now with this virtual world, we're available all the time on this through email, through different concepts. So the fact that we all have industry exposure and have experience and can bring that to the classroom is a huge benefit to you. None of us came into this straight from school. We all went off to industry, worked for years, and then we came back and now we're instructing and passing on some of our knowledge as well as some of the contacts we have in industry, which is of benefit for the co-op program and for yourself. Next slide. Co-op. Our co-op work terms, some of our employers. So this is a listing of possible employers. 75% of these are in the Niagara region. So when you come into the co-op program, which is the technology program, a little bit longer, what happens is your first year you come to school, and then during the co-op system, you learn how to create cover letters, you create resumes, you do practice interviews, you learn how to go to job interviews. Then you start applying to jobs. And these are some of our employers, just a sampling of employers that have hired co-op students. The beauty of our co-op is it's about close to, if not 100% all the time. Basically, the way it works out is if you apply yourself and apply to jobs, you will probably get a job. You know, I can't always guarantee it. It's not 100. I like to say it's 100%. But what it boils down to is the students who participate and are active get jobs. We do have sometimes a student doesn't get a job, and very often it's a student who didn't apply, wasn't interested, didn't quite do what they had to do. But we will help you along with that. You're not left on your own to create resumes. We create them, we post the jobs, push you to apply. These companies are small industries that employ 15, 20 people to some of these facilities employ 1,000 people. So they're very large. Right in the very middle there, the word Indio sticks out. That's a large natural gas generator company in the area. It used to be General Electric. They make large turbines. You can see General Motors on there, FBT Inc. Just these random names. I know all of these companies. 75% of them are in the Niagara region. So most co-ops are in the Niagara region. There's a few that are out if you want. You can always apply to other jobs. We've had students. I had one student go to Brazil in my time here. He wanted to learn about MMA fighting, mixed martial arts, right? That's what MMA is. Yeah, he wanted to learn more about that. And so he actually went on his own and applied to some jobs and got a job placement in Brazil. And he went down there and studied MMA while he was doing his co-op. He found that college isn't going to help you with that one, not when he did on his own. But those opportunities do exist. If you have other contacts that you want to do a co-op somewhere, it's okay to do that, provided it meets the criteria of a mechanical engineering technician or technologist. And our co-op department is very active in assisting you and posting jobs. Right now, we've had numerous jobs posted, even during the pandemic, with everybody being online and virtual. Most of these industries were still running, and our students were still getting co-op positions. And again, they're all paid positions, and they're usually not minimum wage. There's a few that are minimum wage, but most of them aren't. And minimum wage here in Canada in January is going to be $15 an hour, just so you know. But typically they're higher in the $17 to $20 an hour range, and even higher. And then what happens is with this co-op, you make contacts with industry. Very often our students have full-time jobs when they're coming back to school for their last term. In fact, some of them work part-time while they're going to school. We don't encourage this because it does impact your studies, but we've had students who work 10 to 20 hours a week at their co-op employer while they're going to school, because the employers rely on these co-op employees to actually complete projects. You're not just photocopying paper, you're actually supporting the industry. They count on these co-op students all the time, and they understand that they got to train you, but that's what they're there for. Let's go to the next slide. Here's a couple of examples. I had permission from Dowd and Olivia to post their jobs. So Dowd at Tircon, a local company, fabricator. He worked on work instructions, packaging solutions, quality analysis. And then Valbruna ASW, that's a specialty steel manufacturer in Welland. He looked at some specific projects, an ingot dumper, grinding table, ladle teaming card. Now, not necessarily designing the whole thing from scratch, but designing components, looking at quoting it, getting it scheduled and getting it executed. So the various aspects of executing those projects he got experience on. Olivia had her first co-op at the St. Lawrence Seaway, which is, if you're international students, you may not be familiar, but there's a seaway locally that connects Lake Erie to Lake Ontario. And 14, 15 locks. And so that was built many, many years ago, very, very old. So she was working on taking some of those old drawings and old systems and converting them into new ones. She looked at scanner mounts at the lock. She helped with bridge inspection, spending time out in the St. Lawrence Seaway as a mechanical designer. And then her next job was at Post Foods, which is here in Niagara Falls, where I'm located in Niagara Falls. She was a maintenance planner. It's a kind of a cereal manufacturer, and she looked at process flow, maintenance, cleaning wheat, and the cost savings, and resulting in full-time employment. So they both had really good student experiences. Next slide. Career opportunities. Again, all sorts. The beauty of mechanical engineering, technician, technologist is everything you see. Look around where you're sitting. Everything you see has been touched by a mechanical engineer, either in the design, in the manufacturing process, the analysis of it. It's all been handled by a mechanical engineer, has had some input into it. Whether it's aerospace, heavy equipment, primary steel, we think of these big things. And we've had students go into sales and marketing. You know, if you're a good technical sales, if you want to make money as a mechanical engineer, there is a way to make money if you're in sales and marketing. We can work in industry, but I know some people who are industrial hydraulics salesmen, tooling sales. If you're good at that and you want to combine it with some technical knowledge, sales and technical knowledge, fantastic opportunities out there for you to really make some money, to be honest. Manufacturing and production management, you'll see many mechanical engineering technologists, technicians who grow into production managers, operation managers. In fact, I have a couple of examples coming up on the next page, I think. Well, let's go to the next page. Here's some graduates. So Robert Brown is currently a CNC programmer at Horsco. He graduated in 2019. Daniela Cortez, oh, she's in sales. Factory surplus direct. You think, oh, what's that all about? Well, she does automation. So she's a sales rep for this company, and what they do is industrial automation applications, whether it's robots or material handling systems. So she's traveling around selling systems, quoting systems, working to develop that industry. Ben Lawrence is a manager of additive manufacturing, Blue Origin, which is an interesting story because Blue Origin, if you recently watched, it was just recently where they launched 4 people up into space and brought them back. Blue Origin is one of those space systems out in Seattle. They have the Shepard launch system. They send people up and then bring them back down. I think Jeff Bezos is his Blue Origin. So that was his system. Ben was a student in our manufacturing program. He worked in the research system at Niagara College and did a lot of 3D manufacturing. He was actually headhunted from us by Blue Origin, and they moved him out to Seattle. And he's now the manager of all 3D and additive manufacturing for those Shepard rocket systems. They do a lot of, because it's a very low volume system, they do a lot of 3D manufacturing. He has exposure with all sorts of exotic materials and systems. And he's now manager out in Seattle. Seattle, was it Washington? I think it's Washington. So Ben's been very successful at that. He's been a little longer. And Mike Holden, he was a 2011 grad. He worked for me in research. He spent a lot of time in looking at time studies and analyzing time and manufacturing systems. We did some projects on continuous improvement operation with some of the local industries. He was hired as a continuous improvement specialist. Again, different title, not a mechanical engineering technologist. Continuous improvement for Moyer-Diebel in Canada. They are in Vineland. They manufacture dishwashers, commercial dishwashers for restaurants, washing systems for grocery stores, any sort of halls, when you have halls that do catering systems. So commercial dishwashing systems. They also have other facilities that create those rotisseries for the cooking of, let's say, chicken in the grocery stores. They're all made by what's called one of the manufacturers, a company called Moyer-Diebel. And so he moved up through Moyer-Diebel. So it's now 2021, 10 years. So he graduated 2011, and he's now director of operations for that plant, doing his MBA at Brock University. Again, he never got a degree. He got a diploma, the advanced diploma from Niagara College, became director of operations, and through his growth up through management, he started to pursue his MBA, applied to Brock University, a local school, to get his master's in business administration. Without getting a degree, they accepted him. And I've talked with him, and I've talked with some of the teachers in there, and they love having someone like him in their program because he's not just a student of business. He actually has technical knowledge as well as the practical experience that he brings. So you can see that, from starting like Robert Brown, 2019, recent graduate programmer, but you can see that the opportunities exist for you to advance. This is kind of your first step to get you into industry, get you into making those contacts, and then you can grow. So there's a lot of opportunities out there. You just need to take that first step and join the program. Again, we do have what are we now? We're in November. We have a January start and a September start for next year. We filled the program up this year. The students are off on CoOp, and I know the CoOp is really important for those of you out there. I can't stress enough how valuable that is. And as well, the other thing that the slides don't cover, again, that I tried to mention was the full-time faculty. Having full-time faculty with industry experience is important. Make sure when you're going out to other schools, Ask that question. Find out how much full-time faculty is, help you to make a decision.
And, adding to that, Rick, I'd just like to, one moment there, Sergio, for anybody who isn't aware, at Niagara College, we work with community partners we get professional advice from them. Every term we meet as a committee to hear what industry needs, and so that we can ensure our students have that. But Rick, what you were saying earlier is just that we also influence industry, because our grads go out with that state-of-the-art firsthand knowledge. And like you said, the student went out and because of that, that organization bought a 3D printer because of the knowledge that student brought to them. So, I mean, what an amazing partnership we have with these industries and opportunities, right? It goes both ways.
Yeah.
So
One of the reasons they can do that is because we're a laptop program. I didn't really mention that. Maybe we need to create a slide for that. But when you enroll in the program, you get a college, you don't bring your own computer. You can have your own computer, that's okay, but you actually get a mechanical engineering technology, a laptop that we assign you, or you actually sort of purchase it through your tuition. It's not extra cost, it's built into the cost. And with that, by giving you that laptop, and Niagara College has it, it actually comes loaded with software that you then use wherever you are. So it's not the type of program where you have to come into our labs to work on our desktops. Some colleges, you go to that, and if you want to use the software, you have to be on site on campus. That's not here. You have a laptop. It has about $100,000 worth of software on the industry software. And that way you can use it at home. You can use it at school. You bring it with you to class. You actually take it off on CoOp, and you use it when you're on CoOp, unless that employer gives you one as well. That's okay too, which then makes you a little more of an expert in that software. You know yourself, and I know myself. If I'm given software and I show how to use it, great. If I don't use it often, I forget everything. I need to use it. And so the more you use it, the more expert you become. So that is a benefit of the program with the laptop, is that you do become very expert in all these industrial applications and all the software associated with it. And we'll teach you with it. So the nice thing is, when we went to virtual online, when we had to because of this pandemic, our students already had all the software on their laptops. It just became, okay, that laptop that you have now, I'm talking you through a computer and we're going through how to use it. They were already very comfortable in that world.
Definitely.
If I could just chime in here a bit, and I'm not sure if this was covered in other areas of this open house, but one of the things that I think we really pride ourselves on is that we know that transitioning from secondary to post-secondary could be a challenge, most especially for our international students. Niagara College offers a lot of great support, and as professors, we'll speak to you in those first few days that you're here, so that you know that there are supports out there for you. This program is what I consider intense. That means that there's going to be a heavy workload, but we provide the resources that you need to get through it. And once you're through it, as Rick mentioned, I mean, the sky's the limit. There's the scope of your skill set, your knowledge and skill set, once you complete this program, is such that you're going to be in demand. But you have to work for it. It's not going to be something that initially it may overwhelm you a bit. But like I said, I mean, we are there to provide the supports that you need to get you through that transition, that first transition, which will be your biggest challenge.
Yeah. So your first year, one of the courses we offer, or two of the courses, we actually take something called computer applications. And a lot of schools ignore this, but it's very important. So we actually have a course, Computer Application 1, where you'll actually spend some time in Word, PowerPoint, and Excel. And you will spend more time with hands-on. So you're in a class. You're not just learning it on your own on the side. A lot of schools consider, well, students come to the school already knowing this stuff. And what we've discovered through our experience is that you think you know Excel and Word, but you don't really know how to use it. You've picked up little things and you've learned how to make things function, but you're not real adept at it. I know my sons, I have a son who's 21 and 25. So they both went through school. And so when they went off, they don't know Excel. The schools assume they knew Excel. And then they have to start doing activities and they're finding, oh my God, I don't know how to do this. They had to pay extra to take an extra course on a weekend to learn how to do those things. We bring that into the program because in engineering, we use Excel a heck of a lot, believe it or not. Even though it's really a business application, we show you how to use it to model systems and to use Solver. And so our advanced features, and then we go into Visual Basic and programming. So we know that those computer skills are important, and it's not just something that you think you know it, but you really don't, and we spend some time on it. So that's kind of a transition, what I look at as a transitory course to get you from high school into university, into college, and you don't really know what you don't know yet until you start using those applications in industry, and they are very, very common. So don't treat that lightly. Even when you go to, if you go to another school, whatever, learn Excel if you're going to go into this industry. Spend time learning it properly, taking courses. We have that within the program. It's part of the hours that you take in that first year.
Just a very quick comment, because what Rick has said really resonated with me in that, one of the things that I appreciate the most about this particular program is that it builds term by term. The courses are connected. So what you learn in the first year, you'll use in the next term, next year, and so on. So that building of the skill sets, the biggest benefit in this program is that it's all in the context of mechanical engineering. So what you learn in terms of concepts, you'll apply. So you're not going to learn math and physics for the sake of learning math and physics. You're going to learn math and physics because you're going to have to apply it to engineering types of concepts. And that's kind of a strong focus for us, especially when the learning builds on a term-by-term basis.
Bye, everyone.
Thank you. Thank you.
Bye-bye.
Bye now.